So starting off today, it says, we know that addition is the opposite of subtraction. Sometimes it's called the inverse operation. And what is division the inverse of? That means they undo each other, right? If I do 3 times 6, what do you get? 18. And then you divide that by 6, where do you come back to? 3, back to where you came from, right? So they undo each other. And then exponents and roots, or radicals, are also opposite, exponents and, roots, radicals are the opposite inverse operations. So for example here, a squared equals b, then a equals the square root of b. And then we have an example, 5 squared is 25, which means the square root of 25 is 5 there. Inverses here is a 5th power, 2 to the 5th equals 32. The 5th root of 32 equals 2. Do you guys remember in your calculator how to do like a 5th root or a 4th root or a 3rd root? So square root's on the front. It's right above x squared. But if you want to do a root other than that, what I suggest, there's a couple ways. Let's say we want to do a 5th root. Okay? That's, we're going to put a 5. And then do math. See x root right there? The 5th option. So hit the number 5 or scroll down and hit enter, and that makes it the root of whatever you just typed in before it. So if I wanted a 7th root, you'd do 7 math 5. 7th root or whatever root, okay? So if you do 5 math 5, the 5th root of 32, we get 2. What does that mean? Why is the answer to that 2? What are we asking ourselves when we're trying to find the 5th root of 32?
A number times itself 5 times.
Yeah, that number of times, whatever the root is. So it's a 4th root. We're trying to find what number times itself 4 times is the number under the root. Just so you know, you can make maybe a note of this. The number or variable or whatever it is under the root is called the radicand. The number or variable under the radical sign is called the radicand. Okay, so what is a perfect square or cube? We talked about that. We did that warm-up last class, right? You guys remember doing that? I asked you what to define a square root and define a cube root. So now what I want you to do, I want you to take just a couple minutes or so, and I want you to answer the 4 questions on the left with this table. Try and navigate this table to answer those 4 questions. So take a couple minutes and do that real quick. Use your calculator if you want. All right, let's see what we got. J-Lo, what is 14 squared? Good. So you come down to 14, and then you go to the squared column. So n squared is 196. Brayden, what is the cube root of 216?
6.
Good. So that one, you guys figure out how it kind of works backwards. So if you start in the cubed column and go to the left, you're taking the cube root of that. Does that make sense? I'm sure you guys all figured it out. So good. The correct answer there is 6. Then it asks us, which is greater? Aiden, what did you get?
I got 7 cubed.
You got 7 cubed is greater? All right, let's see what those are. So 15 squared is 225. And 7 cubed is 343. So I would agree 7 cubed is greater. And then number 4, once again, that's the one where we're kind of going backwards because we're going to start in the squared column. So 361 down here. What's the square root of 361? 19. And then the cube root of 4,096 is 16. So which one is less?
That one.
The cube root of 4,096. Now this table is going to be your best friend. Okay, so don't lose these notes. Later in the notes, you're going to need to turn back to the front. I'm going to try and print some out so you just have like a copy of it without the notes. But if I were you, I would memorize like these perfect squares for sure. And you guys know most of those, right? What's 10 times 10? 100. What's 4 times 4? Yeah, it's just these are the perfect squares. That makes sense. So 1, and then you might not know these ones as well. Like 13 times 13 is 169. But I would have those memorized. If you have these memorized, then your life will be much easier. And then the really common perfect cubes are these ones right here. 1 and 8, 27 is 3 times 3 times 3, 64 and 125. You'll see those ones quite a bit. You'll see here what I mean by that in just a little bit. Okay. All right, moving on. Approximating radicals without a calculator. Square root of 12. What does that mean? If I ask you to go run the square root of 12 miles, what are you going to say?
No.
First of all, probably no, because it's no. And second of all, square root of 12. I don't know what that is. Okay? So what I suggest doing is find some perfect squares around it. So what's the next perfect square smaller than 12?
9.
9, right? So the square root of 9. And we can put that on a number line. What is the square root of 9? 3. You know what that is. And then what's the next largest, you can look on your table, what's the next largest perfect square? 16. What is the square root of 16?
4.
So it's between 3 and 4 miles. That sounds a little bit better. Still not great, I don't want to go out and run that far, but the square root of 12, like what is that? Well, it's between 3 and 4. Now, if you had to guess, where do you think it is closer to? A little bit closer to 3, right? Maybe. Because 12 is a little bit closer to 9. Let's try it out. So if you had to guess, let's give this a decimal. So it's a little bit closer to 3. If you had to guess, about what decimal do you think?
3.4.
3.4 sounds good to me. Okay? Put it in your calculator. Do the square root of 12.
Oh, yeah.
Yeah, just barely less than halfway, right? 3.46. So some of us forget that these are just decimals. Like these non-perfect squares. You can still take the square root of them. It's just an ugly decimal. It's called an irrational number when it goes on forever with no pattern like that. Kind of like pi. You guys are familiar with that. We'll talk more about those later. Okay. The square root of 20. What are the perfect squares that kind of surround the square root of 20?
16.
16 again was on the left this time.
25.
And 25. So we know this is between 4 and 5 because the square root of each of those is just nice pretty whole numbers. Now which one's it a little bit closer to?
16.
A little bit closer to get 16 again. So if you had to guess on this number line about what are you thinking?
3.4.
Not 3.4.
4.4.
Yeah, maybe 4.4, 4.5-ish, real close to there. So once again, let's give it a try. Square root of 20 is, about 4.47. Cool? Alrighty. Now go ahead and use your calculator. Just kind of practice using a square root, a cube root, and a fifth root. And it says round your decimal to the nearest hundredth. So this is also a good review of rounding numbers. Yeah, so we get 2.79. We do not have to round that one up. So 2.79. Okay, the next one. Now there actually is a cube root option. You can do 3 math 5 again, or you can just go into the math menu. And then, not 3, because that's cube. Yeah, 4 would be the cube root of -4. And we get, what if we round to the 100th, 2 decimal places, what's our final answer going to be?
-1.59.
Yeah, -1.59, because the number after that's a 7. Okay, so -1.59. And lastly, the fifth root. So you'll hit 5 for fifth root, math, and then you're going to select the x root option, number 5. That makes the fifth root of 99, which sounds big, like the fifth root of 99. But really, it's a pretty small number. Like, I would rather run the fifth root of 99 miles than the cube root of 27 miles. So, 2.5 what? Yeah, 2.51 rounded to the nearest hundredth. I'm not going to stress this too much. I'm not even going to go over this table. I just want to explain a couple things that you probably already know, just refresh in your mind. What is the square root of 100?
10.
Now, that is correct, but there's another answer.
-10.
It's -10. You remember that? Because what is 10 times 10?
100.
100. What's negative 10 times negative 10?
100.
Also positive 100. So when we take the square root of a positive number, we have two answers, the positive and negative version. Sometimes you'll see that written as plus or minus 10, right? Now typically, this will just be your answer. That's called the primary root. But just know there is technically two, okay? But what about number 5? The cube root of negative 27. Is my answer 3 and negative 3?
No.
No, it's asking you what number multiplied by itself 3 times is a negative 27. So what's 3 times 3 times 3?
27.
Positive 27. So that is not the answer. The only answer is a negative number, because a negative number times itself twice is positive, right? A negative times a negative. But what happens when you multiply it a third time? It turns back negative again. So if you multiply a negative number an odd number of times, it's negative, okay? So then number 6, what is the fourth root of 625? You can use your calculator, so do 4 math 5. 4 math 5.
5.
Yeah, it's 5. Is it just 5?
Negative.
It's also negative 5. Right? Because a negative number, an even number of times, is positive. So an even root of a positive number, you're going to have two answers. And then the last one, what's the fifth root of 243?
3.
And negative 3 or just positive?
Positive.
Just the positive one, right? Because there's only one way to multiply a number 5 times at a positive number and stay positive. Because a negative number 5 times would be negative. Okay, you guys already knew that, right? I just want to kind of refresh that. Okay, now, I want you to spend a couple minutes and do this little true or false. Let's do the first one together. So in your calculator, you're going to do the left side of the equation first. So let's go ahead and do this one together. So the square root of 3 plus the square root of 4. And then get a decimal. Now the nice thing about these calculators is you can keep it on the screen, right?
Mm-hmm.
So I'm going to keep that there, and now I'm going to put in the right side. So the square root of 7. Is it true that the left side is equal to the right side?
No.
No, those decimals are not equal. So put an F there for false, okay? So go ahead and go through each of these and do true or false. If you're watching the video for the sake of the time, here are the answers. Properties. So here, you can basically see what we just learned. If you're multiplying two radicals, what do we do to the numbers underneath?
Multiply.
You multiply them, exactly. Okay, now that can happen vice versa. You can unmultiply them, also called dividing, right? So when you have square root of 40, how could I break that apart? So if you get kind of here, I'm breaking it out into two separate radicals. So what times what is 40?
8 times 5.
8 times 5. Does that work?
Yeah.
Yeah, so the square root of 40 is the square root of 8 times the square root of 5. Well, there's other answers. What else could work? 20 and 2. The square root of 20 times the square root of 2. What else would work?
10 and 4.
10 and 4. Now, the one that I'm going to point you to is this one right here. Why do you think I like this one the best? Because what? Look at this number. 1 is perfect. 1 is perfect. What is the square root of 4? 2. So another way I could write this is 2 square root of 10. Right? Because what's the square root of 4? 2 square root of 10. Okay? The next one here. And I'll come back to that in a second. Let's simplify without rounding. So no decimals anymore, okay? For the rest of the class, no more decimals. The square root of 12. I want to break that apart into 2 square roots. Now what I want you to do, go back to the front page of your notes. I want you to find the largest perfect square that divides out of the square root of 12. So 1, 0, 1, 4, 9, 16, so on. What's the largest of those numbers in the square column, because it's a square root, that divide out of the square root of 12? So the largest perfect square was the square root of 4. That means our answer is 2 square root of 3.